Hello, my name is Keith Schultz and welcome to our webinar series. In this episode, we're going to be talking about what's new in NX2312. Enjoy. So first up, we have Face Mill Zigzag. This is a new toolpath and mill planer that is made for milling planer surfaces. Okay, here we are. This is our Face Mill Zigzag. I have my parts set up in a vise. I have it set up on a Haas machine. And let's go look at this operation. It lives in mill planer. Here it is, face mill zigzag. It's a milling operation. It face mills a planar surface. One cut area floor must be specified. Specifying the body is optional. Okay, so we're going to go ahead and populate the rest of our parents. We're going to, for our program group and our tool, we have workpiece and we have a 43 millimeter face mill. That all looks good. So first things first, let's go ahead and select a planar surface up here. Select OK, and we're going to go ahead and let it rip and generate and see what we get. We get our first tool path. It's just a straight path that goes across the top of the part. And that is due to our floor stock condition being 200 microns up here. Another option we have right here is a cut angle. We can actually change our cut angle. So I'm going to go ahead and put a different angle in here. Let's put 20 degrees. And you can see we get a little preview here that shows where the tool is going to be, and it can show the center line of the tool as it goes across. Let's go ahead and generate that. You can see how that works. All right, and right now I'm going to set that back to 0, and we're going to look at our containment. Right now that's set to, yep, that's set to thickness, and it was set to 0. We can set that to blank geometry or 3D IPW. Let's see how that looks. We see a preview again. And we see our operation now taking into account our in-process workpiece or our blank. Some other options we also have in here. We can also change our cut directions as well as our cut order. We can actually alternate our cut direction if we're not happy with going just one direction. You can see how we have two separate tool paths here. Generate that and see what we get there. Very easy to get a toolpath out of this operation. So let's look at some other things in this operation. I'm going to go ahead and create a new operation, and we're going to select that bottom face. See how this works. All the parents, I'll keep those the same. Let's go ahead and select this other bottom lower face, and let's generate that. Let's see what we get. Once again, we get a single line across here because we're only looking at our thickness of 0. We go back to 3D IPW, and you see we actually get the whole part now. We get that preview on the part, but yeah, as you can see, we have a bunch of collisions. All right, so we need to fix that. If we go into our avoidance tab, we'll be able to fix this. So let me show you where that is. So in avoidance, you see we have an option. Go ahead and set that to trim. We generate that again. It's going to trim away those tool passes that give us collisions. And now we have two planar surfaces that are different levels merged together. So that's a pretty awesome way to be able to do this operation. We also have smoothing options in this toolpath as well, so you can smooth out all your non-cutting moves and transfer moves. And once again, was Face Mill Zigzag. So next we're going to look at this merge path planar. So we can take two planar mill paths and we can merge them into one. So let's take a look at how this works. So I have previously created two planar profile operations in my program here. And we can see there's just two separate operations, and we can actually go and merge them together. So let's show you how to do that. I'm going to go to my Home tab, and we're going to go to our Create Program. Go ahead and hit that, and we can see we have a Merge Path Planar there. So we're going to go ahead and select that, show you how this works. All right, you can see we don't have many options. We have this by concatenation and that's our only option. We also have non-cutting moves. Well, since we're just joining two tool paths, that's our only options that we're going to have, basically, is our non-cutting and transfer moves. So if I go ahead and take these tool paths, shift select them, I can then drag and drop them into that merge path, and then we can generate this set. And very quickly, you'll see what we have is a transfer move uh, joining our tool paths. Exactly what we wanted, and it was very quick and easy to do. So that is merge path planar. Let's see our tool coming on our upper level, transferring over and doing our lower level. Once again, that was merge path planar. All right, so next we're going to look at this quick roughing operation. It's recommended for removing large volumes of material on mold cavities and cores. And it's kind of like a cavity mill on steroids. So let's look at this operation. All right, so let's look at this toolpath. I have my Area 51 spaceship mold set up on my bridge mill there, and we can go ahead and create this operation. So here's that quick roughing operation. We've called it a cavity mill on steroids. It's basically cavity mill. There's some presets in here for transfers that kind of help us out. Let's hit generate and see what we get. No, it might take a few minutes to generate because this is a fairly large part and it's going fairly deep. But what we're going to notice with this toolpath is NX is automatically going to change our engage types depending on its open area or closed area. The only thing we would have to change in this toolpath is possibly, well, let's look at the layers first. So we can see on the top layer we came in from the side, and as we start going down, we change into a helix. We change to where we're helixing into the part right at the transition. So NX right now is working its way from the center out. That's based on our cut type of cut pattern, and you can see as we go down, it's going to keep on hitting the areas it can with that size tool. So this is a very quick, efficient roughing method, depending on of course, your cutter and your feeds and speeds. We also have options for our range, cut ranges, and we can also have options for our depth or level first. We can apply smoothing to our passes and also the region size. So that's our quick roughing toolpath. A very quick and efficient way to rough out large areas. So let's go ahead and take a look at our analyzer in process workpiece and let's see what NX did to remove material. We still have quite a bit of material left, but we're definitely closer than we were when we started. We can come in and do some semi-finishing operations before we start our contouring and finishing operations. So that was our quick roughing toolpath. That's, once again, new in 2312. Hope you get a chance to use it. So here's the next thing we're going to look at. We've had Z-level undercut for a while, but NX has added some enhancements in 2312, and let's take a look at what those look like. So I have my parts set up here on my Makino DA200Z, and we're going to go ahead and create an operation. Previously put some tools in here and have stock set up. So we're going to select the Z-level undercut. I'm going to put my barrel mill that I already created. Let's go ahead and go with mill semi-finish. And I'm going to go ahead and generate this once I select my cut area. Simple click. And you see we also have the option here of only machining undercuts. So if we had chosen that flat face, we get that. So we've generated, we can see we have some lines pretty far apart here. I'm going to go ahead and change the step over, the step down, so we have our tool paths a little closer together. And there we go. You can see the space that we have as we're transitioning from shallow to steep. That's going to leave a really large scallop. And we can go ahead and change our cut levels to optimize. So that's our improvement right there, is that we've added this optimized cut levels. And when we do that, you can see we've got our cut levels, our tool paths a little closer together, and that's going to help us with our scallop heights as we're transitioning from that shallow area to a steep area. You can run that, see how it looks. And we're only on mill semi-finish here, so we're not coloring it out completely, but you can get the idea. So that's the big improvement, is that we added that optimized cut levels. That's going to make it a lot easier to, when we go in and finish, especially, we can get a little bit more material off, a little bit more evenness when we move material, and less scallop height. Okay, so next we're going to look at this new tool path called Wall Finish Barrel Swarf. There's a lot of options on this one, so we're going to spend quite a bit of time on it, and I think you're going to really enjoy this tool path. So I have my little arrow part set up in my Sim 08 mill, Siemens mill, and we're going to look at these operations. I have a whole bunch of roughing and operations. We're basically down to some contouring operations for this part. So I have two set up. Let's go ahead and hide this mill so we can get around the part here. There we go. I have an inside pocket scenario set up, and I have an outside scenario also lined up here. So let's look at what the operation looks like. See in our window, because new in 2206, I believe it was, we started to get these prediction windows, and we're going to see some of our most used options. So in our main tab, we can see what we need to specify. So I had to come in here and specify the walls. I selected all these exterior walls as my wall geometry. We also had to specify an upper curve. I had to select a few different curves here, and our lower curve. So this is going to determine the geometry that it's following. I'll hide that toolpath real quick. And then we have a couple more options here. We can either do zigzag, we can do zig, and we can actually do spiral. So actually, that's a pretty good illustration of how you can use that around some kind of a round part that has a draft angle in it. So that'd be a really great finishing or semi-finishing option you can have. We also have some options on if we go with just an upper curve, just the lower curve, and the upper and lower curves. Now this offset from guide can be useful if you didn't have, you can see in the graphic we have here, the bitmap image, if you didn't have actually a good guide, a good solid guide, if there was some geometry in here that wasn't straight or linear, we could actually go and draw some geometry in here with a sketch and actually use that as our guide. We can offset from that guide. So that's a good tool to have. We also have our step over, which we can either do in a nominal size, a percent of tool diameter, or a percent of flute length. I'm not sure if it uses the total diameter at the top of the tool, or I'm guessing it probably uses that. And we know we have the flute length, right? So right now it's set to inches. That's the default setting. Let's look at geometry. So this is normal. We have whatever geometry we select to make sure that you have a part defined, so you can track your IPW. The part's already defined through our geometry group. You can see that under the blue skin of the selected geometry for our faces. And we also can specify a part stock in here. We can also have optional geometry if we had some kind of a clamp on here that we had modeled in. We could actually put some optional geometry in there. So looking at the next tab, we have some access and avoidance. And this is special to the wall finish barrel swarf toolpath. We have this show contact preview for the tool. This is pretty interesting. This is one of the interesting previews about this operation that has tool settings actually in the Windows Explorer window here. And what we see here, this is actually not the default. I've been playing with this. We can see we have these contact heights. I use this little show contact height preview, and it's actually showing our contact height here. And our preferred is in green. I believe that default value is 5. Our minimum is this pink or red value you see down here. That's 3. And our maximum is 0.8. I'm sorry, I didn't put the decimal in there. And you might be wondering now, what is that referring to? How large is this tool? It's pretty interesting. The tip of the tool being 0, and the top of the cutting portion of the tool being 1. These are all values, nominal values, percent values of 80%, for the maximum 30% from the minimum, the preferred 50%, this green line right here. So that's used in the tracking of the tool through the operation. And actually, I'll show you that it gives you different behavior. So if we move this tracking point up a little bit, the tool is going to tilt a little bit more this way on the on its axis. If we take this tracking point and we move it down, you'll see going through the this being the cutting side, of course. You'll see the tool will tilt out a little bit more to make the that actually the preferred contact point. All right, now that we've done that, let's see how this looks on the part here. I'll get it set up. So I've got my IPW displayed, or I did momentarily. I have my IPW displayed, and now we can go ahead and animate this toolpath, and we can see how this tool runs around, and it's using that preferred contact point, and it's tilting away from the workpiece. And this is I don't have many stepovers. We'd actually get a pretty decent result with fewer stepovers, but we can see how when we get into the corners here, into that blend, that edge blend over here, that there's a little the tool is going to try to maintain an axis that's kind of tangent to that surface, so it's gonna dip out a little bit and tilt over. So let's see what that's going to look like in a machine. So I went ahead and made my machine visible, and I'm in a machine simulation. So let's see what that looks like. You can see that little tilt in that axis there to get around that edge blend there. You can see how that runs across, back and forth. All right. So let's show you a couple of other scenarios. So here we have a toolpath. We're on the inside. I've got 3 stepovers. This is a zig mode when we're doing a climb cut. And let's see how that works. I think I did a step over or something like a 1/4 inch or something like that for that one. Speed this up a little bit. And we can kind of see how we get those nice large scallops. We can see, we're about to see how we get those scallops when we look at the tool. So let's look at that tool. So I've pulled up our tangent barrel tool, and we can look at some of the parameters in there. So we can see how this tool is defined. So the diameter is going to be this top area here. That's 0.375. That's the same for the neck of the tool. And that barrel radius, that's the tip down here. So that's 2 inches, not the tip, I'm sorry. The radius of this part right here, this barrel, so this is a 2-inch radius going from the top of the tool over the 1.5 inches of the tool. And the lower radius is, that's 0.075, and that's how this tool is defined. And you can also put in your materials of the tool and everything like that. So here's our first scenario where we're doing just a zag cut. You can see our high-speed moves back into our engage cuts. Let's see how that looks like. You can see we do nice little high-speed loops, kind of like helixing down across the part, efficiently removing material. And here's that zigzag pattern. That's just basically going back and forth, climb cutting and conventional cutting with these high-speed loops in here. Let's see how that runs. And these options are right here on our cut pattern and our main. So we talked about our access and avoidance, how we use our contact height to define our tool, and we looked at our tool already. We have some access and avoidance options here as well as clearance options. Strategy, double dependent. We only have 2 options for either zig or zigzag, so it's either going to be climb or conventional here. And we can either separate this by level or region. We can select multiple regions. Feeds and speeds are feeds and speeds. And within our non-cutting moves, we have very few options. You see, automatically we have what we normally would like here, but we can see we can change our arcs, our transfer types, or blend spine, or clearance. Blend spine is what's making these loops right here. If we change this to clearance, we'll probably see more retracts, and our clearance is set automatically to 118 thousandths. So I've got another part set up here. There's something I wanted to show you, and that's about our tracking point, and that's and getting down into corners. So NX is automatically going to come back into these. Let me get this straight here. It's automatically going to come back in these corners and tilt that tool out a little bit more to get more of this blend corner. As you can imagine, if we didn't have those additional moves that come back up, we'd have a lot of material left. So NX is automatically going down to that minimum tracking point uh, and actually removing this material in here. And one other thing of note on this toolpath, you're actually, we can't actually cut with the tooltip. We will cut with the tooltip, but it's not designed to cut with the tooltip. So that was our wall finish barrel swarf toolpath. Thanks for joining us on this episode. We hope you join us next time. And for those that are live here right now, I guess we're going to open it up to questions.